this is section 2.2 on the basic derivative rules and rates of change. And like I said before, this is going to be the beginning of some rules that I'm going to teach you guys about how to find derivatives much quicker than replacing the x's with x plus the change of x and going through that whole limit process that we've been doing. Not that that's not valuable, that's actually what you're doing, but these are just some of the shortcuts that you can use. All right, so the first derivative rule is called the constant rule. If f of x is equal to c, in other words, if the function is equal to some constant number, say, well, we'll talk about an example in just a minute. If f of x is equal to c, then the derivative of f of x is equal to 0. So, an example, if f of x is equal to 5, what's the derivative of f of x?
0.
It's 0, yes. Think about that. F of x is equal to 5. That is a horizontal line at 5. What is the slope of a horizontal line? 0. So the derivative of f of x is equal to 0. Add that into your notes, please, if you didn't already. The power rule. This is one of my favorite rules. Called the power rule. If f of x is equal to some x to an n power, then the derivative, the derivative of that is equal to taking this power, putting it in front of the x, and then subtracting 1 from the power. You did that last year? Oh, he taught you that last year? I didn't think he did. Okay. All right, so the derivative of f of x is equal to n times x to the n minus 1 power. So, an example of that is this. If f of x is equal to x to the second power, what is the derivative of f of x?
2x.
It is 2x to the, remember to this power right here, you got to do 2 minus 1. What's 2 minus 1? 1. So it would be 2x to the first power. But that's awkward. You don't write 2x to the first power. You write 2x. G of x is equal to x cubed plus 1. Well, the derivative of that is going to be then, of course, that you take this 3 and you put it in front and you take away 1 from the power. So g of x, the derivative of g of x is equal to 3x to the power of 2. Very nice. What about this, though? What about plus 1? Well, what is the derivative of a constant number? 0. 0. So it's actually 3x squared plus 0. Well, that's awkward. All you need to do is write 3x to the power of 2. Okay? So, would you choose to do this, or would you choose to go back and do the limit as the change in x approaches 0 of course you would. Yes, of course you would. Right. Kind of would. All right, the power rule, where are we now? The sum and difference rule. You need to start writing again. The sum and difference rule says that if h of x is equal to two functions added together, f of x plus g of x, then the derivative of h of x is equal to the derivative of each one of them individually and then added together. Pause. So in other words, if you have some function that really is two other functions, two pieces added together, you find the derivative of each piece and you put them together. I'll show you an example. It will make sense. So h of x is equal to x cubed plus x squared plus x plus 5. Technically, you guys, this is 4 functions added together. X cubed is a function, x squared is a function, x is a function, 5 is a function. So all you need to do to find the derivative is find the derivative of each one of them individually and write them all out, one after another. Don't make that rule harder than it is. So h of x is equal to x to the third power. How do you write the derivative of that?
X squared.
Yes. 3x to the power of 2. What about x squared? What is the derivative of x squared? 2x. So I'm going to add it in. Plus 2x. What is the derivative of x? It is 1. What is the derivative of 5? 0. So don't add a 0 at the end. So the derivative of x cubed plus x squared plus x plus 5 is actually 3x squared plus 2x plus 1. Would you still go back and do it the old way? I already had to buy into it.
How did you get that again?
I took this power of 3, put it in front, subtracted 1 from the power. 3x squared. Then I did this one. I put the 2 out front, subtracted 1 from the power, so it got me 2x to the 1 power. Here, this is x to the first power. So I put the 1 out front, making it 1x to the 0 power. So let's talk about that. 1x to the 0 power. What is x to the 0 power? No. Anything, any number to a 0 power is 1. Yeah. So this is really 1 times 1. So in other words, if you have a linear function, say x or 2x or 4x, the derivative of those is just going to be 1. Or it's going to be 2. Or it's going to be 4. Okay. All right, the constant multiple rule. The constant multiple rule says this. If h of x is equal to some constant number times the value of the function, then h prime of x is equal to that constant number times the derivative of the function. And it never usually makes sense until I show you an example, and then hopefully it will click here. So h of x is equal to 3 times x squared. Well, according to this rule, all you need to do is write down 3, and then you take the derivative of x squared. What is the derivative of x squared? 2x. I thought you said 3x. You said 2x, right? Okay, all right, good. 2x. So it's 3 times 2x. Clean that up. 6x. So let's talk about that. This rule is there for a reason, but let's just, okay, so we have 3x to the second power. 3x to the second power. The derivative, you take the 2, you used to just take the 2 and put it in front, but there's a 3 in front, so all you're really doing is multiplying 2 times 3, subtracting 1 from the power. So 2 times 3 is 6, subtract 1 from the second power to get you the first power, which is equal to 6x. So this rule is wordier than it needs to be. You just take the power, you multiply it by the coefficient, you subtract 1 from the power. Examples. Let's do some examples. Because, of course, those examples that we talked about are not bad, but then I'm going to throw some homework at you and you're going to get weird things like 1 over x squared and you have to find the derivative. Now, you certainly could go back and do it the old way, but we're not going to. Find the derivative of these 3 functions. So f of x is equal to 1 over x squared. The first thing that we need to do is make this look nicer. So we need to go back to, I don't know what grade, maybe Algebra 2, maybe even before Algebra 2. Maybe you have some recollection of it happening last year. 1 over x to the second power is also known as x to the power of negative 2. Do you remember that? If you move something from the bottom to the top, then it changes the sign of the power. So this x squared is on the bottom. We don't have any rules for finding the derivative when that function is on the bottom, when that x squared is on the bottom. So what we need to do is make this so that it's not a fraction anymore. To make it not a fraction, you just take this x squared, you move it to the top, but you change the value. You change the exponent to exactly the opposite of what it was. So it becomes x to the negative 2. Now follow the rule. So the derivative of f of x is equal to, let's follow our rules that we just talked about above. You take this power of negative 2 and you multiply it by the x out in front. So negative 2 times the 1 out front is -2. X to the, what's the rule? What do you do to that power? You subtract 1. So what is -2 minus 1? -3. But it's not okay. It is not okay to leave this with a negative exponent in it. So we need to make it positive. So to make it positive, we put it, we have to move it to the bottom to make it positive. That's the rule. If it's on the bottom, you move it to the top, it switches signs. The same thing if it's on the top, to move it to the bottom, it switches signs. So this is equal to, we have a -2, and then this x to the -3 power, to make it positive, has to be moved to the bottom. What I'm concerned about is a lot of you will move the -2 with it. You got to leave the -2 there. This only works for the x value. So you put that on the bottom, you change the sign, so it's x to the power of 3. Okay? Try the next one. 1 over x. Yes. Got one up there? 1 over x squared? Like when you say, you mean how did I do this? Okay. So you had 1 over x squared. I have not taught you any rules about finding the derivative if you have a polynomial on the bottom of the fraction. I haven't taught you any rules. So what we did, we kind of cheated, and we moved it to the top. And that was a rule that, an exponential rule that you, not exponential, an exponent rule that you learned years ago. It's probably not right at the front of your head right now. It's probably at the back of your head somewhere. But it told you that if you have a power on the bottom, can I have all the side conversations done and over with, please? You could just move it to the top, and the value of the exponent becomes exactly the opposite of what it was. And I knew if I moved it to the top, then I could use the rules that we talked about above to find the derivative. Okay? And you need to get comfortable with that, because you're going to have to be doing a lot of that, switching back and forth, okay? F of x is equal to 1 over x. Same thing. This is exactly the same as having 1 over x squared. The only difference is that we're talking about x to the first power. So f of x is equal to 1 over x really means x to the what power, you guys? -1 power. I just move it to the top. I change the value of the exponent. All right, so the derivative. Samari, pick your head up, please. The derivative. You take -1, you multiply it by the coefficient. It is -1x. But what do I do to the exponent? Subtract 1. So you have -1 minus 1 is -2. This is improper to leave. It's improper to leave it with a negative exponent. So we're going to make it positive by moving just that part to the bottom. You leave the -1 on top. You move this to the bottom. So the derivative of 1 over x is -1 over x squared. Let's try this one. A minute ago we talked about square roots and stuff. Do you remember that a minute ago? The square root of x. We have no rule for finding the derivative of a square root, so let's make it not be a square root. Remember, this is x to the first power, and there's an understood 2 there. So this really means x to the 1.5. Don't write it as, well, you could write it as 0.5. You could. X to the 1/2 power. Take this 1/2. Multiply it by the 1 in front of the x. So the derivative of g of x is equal to 1/2 x, subtract 1 from 1/2. What is 1/2 minus 1? It is -1/2. Well, that's weird. So I'm going to take this thing, and I'm going to move it to the bottom. And when I move it to the bottom, it's going to become 1 over 2 divided by to the 1/2 power. That's still strange though. What is the 1/2 power? What does that mean? It means the square root. So this really is 1/2 divided by the square root of x. But that's still weird because we have a fraction divided by the square root. It's square root of x. And some of you may have seen this coming a long time ago and already had it flipped and switched around your head, and that is certainly fine. But you have a fraction divided by this. That's the same thing as dividing by the square root of x over 1. So I'm going to multiply by 1 over the square root, 1 over the square root of x, which really means you have 1 over 2 square roots of x. And like I said, some of you can get there quicker in your head, but yes?
So you can't leave it at 0.5 over square root of x?
0.5, yes, you can do that. Yes, yep, you can. Yes?
Instead of doing that on work, couldn't I just see that, like, x is 1/2, take the 1, put it on top, and then put the 2 on the bottom of the square root of x?
You know what, I lost you at can't we just? And okay, listen, I'm not even going to go there. And the reason I'm not going to go there is because it makes me nervous for you to find patterns like that, because once we start throwing in other stuff with this, I don't know that those patterns are going to work.
Because, like, if it was x to, like, say, if it was x 2 over 3, then it would be 2 over 3 square root of x, right?
I don't know what's top of my head. I don't want to have this conversation.
Okay.
Wait, what? Sine and cosine. A couple quick rules about sine and cosine. A couple things you need to commit to memory. If f of x is equal to the sine of x, then the derivative of f of x is equal to the cosine. You just need to commit these to memory. We could go through all the math, but actually I probably couldn't even do that right now, but if we went through all the math, and at some point I think you would be able to, but you would figure out that the derivative of the sine of x is equal to the cosine of x, you need to commit that to memory. The derivative of the sine of x is equal to the cosine of x. The derivative of the cosine of x is equal to the negative sine of x. G of x is equal to 2x squared minus the cosine of x. So the derivative of that, two pieces. So you find the derivative of one piece, find the derivative of the other piece, and you put them together. So we have 2x squared. What's the derivative of 2x squared?
4.
4x. Are you okay with that? 4x, you do 2 times 2 is 4. Subtract 1 from the power, you get 1. We have a minus sign, so I'm going to go minus. What is the derivative of the cosine of x? Negative sine of x. So we're subtracting a negative sine of x. That really means 4x what? Plus the sine of x. All right, let's try this. A few more examples, and then I'm going to stop. F of x is equal to the cubed root of x. Rewrite it. The cubed root of x really means what? X to the 1/3 power. So the derivative of f of x is equal to 1/3 x to the 1/3 minus 1. It's negative 2/3. Negative 2/3. Take this x value, where are you going to move it?
To the bottom.
To the bottom. And if you recall from the math that we did in a previous example, that is really the same thing as 1 over 3x to the 2/3 power. Yes?
Wait, why is it not negative 1/3 in front of x?
Well, the cubed root of x is the same thing as x to the positive 1/3 power. So you take this positive 1/3 power, you multiply it by the 1 out in front. But then you have to subtract 1 from 1/3, that gets you negative 2/3. This negative 2/3 is a power. Negative 2/3 is a power. So you move this whole thing to the bottom of the fraction and you change the power from a negative to a positive. It's awkward to leave a term with a fractional power. So let's clean this up. 1/3. How do I write x to the 2/3 power without a fraction in it? Yes. The bottom is what goes out front. It's the cubed root of, that's a cube, by the way. It's a cubed root. Oh god, I gotta try that again. A cubed root of, and then the top is the power. So it's x squared. So your final answer here, let me write this nicer. 1/3 cubed root of x squared. Yeah.
Never mind.
Just the shorter process, but I'm clicking my brain as well.
Yeah, but can you imagine having, I mean, if you had to go through and figure out the limit as the change in x approaches of the cubed root of x?
True.
This confusing too.
Yeah, I agree, but you know what, most of the reason that this is confusing you guys right now is because of all these little rules, which are things that you talked about a long, long time ago. So it might take a few days for them to come to the front of your head. Yes, Lillian?
So like when we did the example before, you get the square root of x and then you have to multiply by the reciprocal. But how come in this case you get the cubed square root and you don't have to multiply?
I multiplied by the reciprocal because I had, I think it was 1/2, help me out here you guys, it was 1/2 divided by the square root of x. Well, that's what's going on here too. I did the math for this one to show you why we came up, remember I went, that's the same thing as dividing by the square root of x over 1, so I went, okay, we're going to multiply by 1 over the square root of x. Those would cancel out, and then I did it on the top. So we ended up with 1/2 square root of x. So I did all the math there, but here I didn't because I knew, I only did it once, I guess. I didn't do it again because I thought that the process you would just know what to do. Maybe I should have went through it. But notice that when I started with 1/2 and I divided it by this, here on the same thing, I'm starting with, where did we have that? Oh, we don't. This is a different kind of problem.
So there's no math.
Yeah, there's no square root, there's no root on the bottom. I was thinking that there was. There isn't. This is a totally different problem. That's why, because it's a different problem. It doesn't show you the same thing. Yeah. But I'm okay if you are okay going from this 1/2 divided by the square root of something or the cube root of something right to this, I'm okay with that. You don't have to go through all those steps again. Yeah. Yeah.
When you went from 1/3 x to the power of negative 2/3, how did you get 3x? You get what I'm saying? In the middle, where did you get the 3x?
This, how do I go from here to here? Okay. You know what? This is what you were talking. I think this is what we were talking about. We have 1/3 x to the negative 2/3 power. So I took this and I moved it to the bottom. So I really had 1/3 divided by x to the 2/3 power, which is really 1/3 divided by x to the 3rd power over 1. So I multiply by 1 over x to the 2/3 power. These cancel out, these cancel out. On the top I have 1 over x to the 2/3 power, which leaves me with 1 times 1, which is 1. And then on the bottom we have 3x to the 2/3 power. So Lillian, this is what you were talking about. Yes.
So you just skipped that.
Yes, I skipped it all. Because I did it all, thank you. We did it all on the previous problem, okay? Anything else? I'm gonna go through this one. 7 sine of theta minus theta, it will take me 30 seconds, and then I'm gonna stop talking, believe it or not. See, that's supposed to be funny because the class is over in 1 minute. All right. What is the derivative of the sine of theta? Cosine of theta. But we have a 7 out front. So that means that the derivative of this is going to be 7 cosine theta. What's this right here? Theta, you guys, is like having an x. What's the derivative of x?
1.
1. The derivative of x is 1. So we have 7 cosine of theta minus 1.
Done.
Done. Well, no, but yes.
You're never done.